of you. And so what you do when you're looking at a fractional exponent, I'm going to start with an easier one. I'm going to start with number 11. So the 2 is the denominator, right? So the denominator goes outside of a radical, and you keep the other part as 16 to the 5th power. So the numerator is the power. The denominator is the index of your radical. Does anyone know 16 to the 5th power in their head? No, right? So you don't want to start with 16 to the 5th power. You want to start with the square root of 16. So what is the square root of 16? 4. So I still don't know 4 to the 5th in my head, but I could use my calculator. What is 4 raised to the 5th power? Do you need a copy of this?
No, I had a calculator that I took my test with, and now I have no idea.
Was it yours?
No.
You have that one if you want.
Actually, I think it's
Yep, so 1024. And that would be one that obviously you need a calculator on. I want you to do the ones that you don't need a calculator, because or else you could just type the whole thing into a calculator. Let's look at number 10. The 4 goes outside the radical, and -3 is the power. So you're going to start with the 4th root of 16. So what number times itself 4 times gives you 16? So I start with 1. It's not 1, because 1 times 1 times 1 times 1 is 1. Is it 2? What's 2 times 2 times 2 times 2? Yes, that's 16. So the 4th root of 16 is 2, and now I need to do 2 to the -3rd power. Yep, so I do 2 cubed. 2 cubed is 8. But the negative is the reciprocal. So the answer is positive 1/8. So we've got to get more comfortable with that negative exponent being the reciprocal. Okay, you tried 12 through 15 now. At least set them all up. I think on one of the practice pages today that I made, it just says set it up. You don't even have to evaluate it. So you're trying 12 through 15 before we on these. So I think, did we all get that the cube root of 64 was just 4? So that one should be pretty easy if we know our perfect cubes. Okay, so the parenthesis is important because when I do my cube root, the whole -125 is under the square root. If the negative wasn't in a parenthesis, let me just show you how it would look different. We could just do the cube root of 125 squared and just make the answer negative at the end. So think of it as this would be like -1 times 125 to the 2/3. The negative is almost unattached, but here because the parentheses are there, the whole thing goes under the radical. So the cube root of -125 I can do because I have an odd number of -5s, right? -5 times -5 times -5 would get me back to -125. So the cube root of -125 is -5. And then that's still in a parentheses. So when I square the -5, what do I get as my final answer? Just positive 25. So if it had not been in the parentheses, what would have happened at the end? This still would be 5. This would still be 5 squared. The answer would be -25 at the end. So the parentheses kind of make it so that the squared cancels out the negative. If it's not in parentheses, your answer is going to be negative at the end. Some of you, when you plug things into your calculator, you're lazy about using parentheses. It's going to change your answer to this problem. What is this, the 2/3 power? So if I do -125 to the 2/3 power. So I just want to show you, if I type it into my calculator, see how the first one I typed in parentheses and it came out as positive 25? The second one I did not use parentheses and it came out as negative 25? Right? There's a big difference in those two answers.
So if you just do it without parentheses, and if it's negative, you just switch it to positive again, and you do that? Does that work for everything?
It might not work for something like, you said switch it at the end, but
Right.
what if
So
I
you
get
just-
negative 64? Like if you were cubing it at the end, it would stay negative.
Well, say you just decided to ignore the parentheses, and if you got negative 25, but in this case, the answer is positive 25, can you just remember that?
I guess a problem like number 15 is what I'm trying to think of, because if you raised something to the 5th power, it would still stay negative. But I can't even do this problem from the beginning, right? Because I can't take the square root of negative 16. So I think it would work for all cases. I would just double check. 1 to any power is always 1. So this one, you've got a negative 16 under a square root. So this is no solution. The reason is, if you tried to say that the answer was negative 4, negative 4 times negative 4 would give you back positive 16. And I started with negative 16. So I can't take the square root of that. But if it was not in parentheses, so if I did parentheses negative 16 to the 5/2, it'll tell me non-real answer, right? But if I do negative 16 to the 5/2, it'll let me do it, because it's making the answer negative at the end. So just be careful with parentheses, I guess, is the moral of the story. Okay, take a look at 306. This page is really short, so that's why I was anticipating doing like 307 today and doing a quiz tomorrow. I just think that there's kind of a lot of volume of stuff, so that way if we spend tomorrow, we spend today doing like extra practice stuff, and then spend tomorrow doing the 307 quiz review. That way the quiz can be on Thursday instead. So this is another, just kind of using your table of powers. These are called solving simple exponential equations because they all come from the table of powers. So like 2 to what power would give me 8? So we're going to do all these in our head. So x would equal 3. What about number 2? 3 to what power would give me 9? So y, equals 2. Okay, try 3, 4, 5, and 6. The bottom ones I might have to help you with in a minute. But they should be pretty mental math quick problems. So 5 to what power is 125? So t has to equal 3. 6 to what power is 1? Right? Anything to the 0 power is 1. 10 to the first, so y has to equal 1. And number 6, if you've got 5 to the 6th, you must have 5 to the 6th, right? So all of those I could do without a calculator, just knowing the power families. 7 through 12 are a little bit more challenging because they deal with negative or fractional exponents. Does anyone know 3? Yep, it would be negative 2 because you flip it over and square it. Number 8, some of these you might have to look back at your power families. Why don't you try, kind of as a challenge, 8 through 12. See which ones you could think out or use your power family. So at least you've tried them first. So there's a couple tricky ones on here. 8 and 9 aren't as tricky as maybe 10 through 12. So number 8, Yeah, so there's another way that we can do it if we can't do it in our head. What did you say number 8 was? It'd be 4, is it to the negative 4th, right? Because to get to 256, it'd be 4 to the 4th, wouldn't it? So it would be the negative 4th. This one is kind of going the opposite direction. I'm starting with a 4th, but I have to flip it to get up to 16. So the negative 2, oh, so it's t, whoops, t equals negative 2, right? Because I'm flipping it and then squaring it to get 16. Maybe 10 you could have done in your head. We know that 7 squared is 49, right? So what would x have to be to make it true? X would just have to be 1. Same thing, I guess, with 11. We know that 3 to what power gives me 81? 4. So 2x has to equal 4. So x would have to be just 2. So maybe you could do those in your head. I have a hard time doing 12 in my head. So I'm going to show you the strategy we're going to use later for more challenging ones. You're going to make them both have the same base. 5 can stay as a base of 5, but 25 I'm going to write as 5 squared. So I haven't changed the value of the problem because 5 squared is equivalent to 25. What am I allowed to do with my exponents here? I can multiply, right, and get 2x. So I can write 5 to the negative first equals 5 to the 2x power. This is called changing the base, and now this is called using the one-to-one property. We're going to see this later in the unit, but 5 and 5 are the same, so I can just skip up here and set my exponents equal to each other. Negative 1 has to equal 2x. Solve for x for me. How would you solve for x? Divide by 2. So I would not be able to get this one in my head. I would have to use algebra, so you probably would also have to use algebra. This is called changing the base, and then this is called the one-to-one property, so you can set your exponents equal. We're going to get to that later this unit, but there is a time when you can't use just maybe mental math. All right, so you've got about, what, 10 minutes? I'd like you to try the back page 305, 306. See if you can do the fractional exponents and then solving for x like we just did. And I, excuse me, can check them for you.